Hello and welcome back. So today we're going to talk about creating branches and doing that from a specific commit. Once again, that's a point in history, a unique point in history with some amount of changes. And we're going to talk about what branching really does for us. We've seen them before, and we've seen them so far in all of the different videos that we've made, but really what it allows you to do is to organize and compartmentalize different pieces of code or different experiments, different versions of what you're trying to accomplish. So you don't necessarily lose that work that you may have done on a previous revision that might be useful in the future, and so on and so forth. And of course, everything is kind of centrally tied to branches inside of Git. And then, of course, we'll talk about some symbolic references that exist and how you can kind of work with those. We'll make a light mention of actually tagging your commits with a specific named version, which can become helpful. And then we'll talk about what a Git patch really is. So, as always, the website for Git has wonderful documentation, and there's even a book, which really will talk about everything that you could possibly need to know. Hopefully, the way I've summarized this in the videos has been a condensed version of actually reading through all of this. Now from here, this page on branching does actually have some wonderful graphics and summarization of a branch. The way that I kind of think about all of this is that maybe I'm experimenting or developing something new, and I want that separate from a main central branch, typically named master, that is the stable version. So everything will run, and that's what I can put out into the world. And I'll go and do some other work that might not be ready inside of a new branch, or I might separate new features that I'm adding to a particular project inside of a new branch. It's somewhere where you go do some work before you bring it back into the stable production version. And this documentation page talks about hotfixes, and what a hotfix is you did some work in another branch that wasn't on the main branch, and now you want to send it to production, quote unquote. And this is accomplished in our organization by submitting a pull request, which is GitHub's fancy way of automating something called a patch that you might create and submit to whoever is the central maintainer, the person who actually manages all of it. And we've seen this so far. You check out a branch or you create a new branch with -b. Let's go ahead and just show what's being done here. So let's say I want to create a new branch that we'll name branching example. And if I want to send that to my original or to my GitHub copy, let's go ahead and double check what remotes we have available to us. And I want to send it to my own fork, which is here, which we've named upstream SAN. And we'll git push-update upstream SAM. And we'll add that branch. As you can see here, it said, hey, by the way that we're tracking this so far, it doesn't seem like there's one that's actually been created there. So if you want to push that branch and set the remote only for that branch as this upstream, you can do this. This is just a shorthand. And of course, if we go ahead and we do git log, we can see, okay, we were in the branch get to, and we've created this branching example, and now that's where we're at. And branching example has checked out from here, or it has started from this commit on, because that was the state that we were in before. Now, if I wanted to actually, and that's what this diagram is showing: commit 0, commit 1, commit 2, and now both of these branches point at that commit. We can also do git log we can also do this to do a nice little pretty printed version of what's going on. And this is why it's so important to add those 80 character headline options, is you get a very good idea of exactly what was going on in those number of commits. And it's fully captured. So from here, what I actually want to do is I want to go back to wherever the master branch was. And I'm sure there's a shorthand for this, but I don't remember exactly what it was. So I'm going to go back here, and I'm just going to look for where the latest status of the main branch inside of the main mixtures repository was. I want to revert back to that for where I am right now. And so what you can do for any branch is you can git checkout, and we'll say this is a new branching. Well, let's say from the branch I'm currently in, I can git checkout this commit. And you'll notice that we're in something called a detached head. What that means is that the reference head that points to a certain commit. So you might imagine head for this is 53 branch points at commit 2 in this schematic. What it means is that we are able to kind of mess around without tracking different versions inside of any of these other branches. Really, we're treating a single commit as its own branch when we've done this. And you'll want to create a new branch out of that if you want to save some of those changes. And that's largely how you can fix the detached head state, is you actually make your changes if you need to and create a new branch with those changes and then remerge later back in at this point in time in order to keep track of separate versions or different branches of your code. So what we're actually going to do is we're gonna get back out of this, git checkout. Did I call it branching example? Yeah. All right, and we're already right back to where we were, which is why it's handy to create these branches. You're able to kind of flip around relatively easily, and there's another way you can do that if you wanted to switch in different places in the ledger within one single branch, and that's called tagging. We'll get to that later. So what I also want to point out is you can git checkout -b. We'll call this one new branching example, and I actually want to go back to that one commit. This creates a new branch. We can do -B if we either just want to reset this branch. Yeah, so -b creates a new branch, -B checks if a branch already exists and resets it to wherever its former head state was, or to this commit. Or if this branch doesn't exist yet, it will, just to make it very, very literal, with B, it'll check to see if this exists or not. If it doesn't exist, it will create it, or it'll do everything I just said. But yeah, we've done that, and now pretty equals 1 line to the last 5. So as you can see, we've actually gone back in time now. We've set the head reference for the new branching example to be at exactly this commit before we made any of those other changes. And that's how you can go back in time to kind of recover whatever it was that you may have already saved and overwritten, or maybe there's a whole bunch of new work that's gone on and you need to take some fundamentals and not include those at all and create a separate version entirely. So now that that's kind of covered, the real reason why these branches kind of exist is so that you can have concurrent development going on the same file, and you can have as many different versions that people are working on as possible, and they're all named something so you can keep track of it. And typically this is done to perform what's called a hotfix, where maybe some new work is occurring in commit 3, and you actually have something broken out in production. So you want to create a new branch that doesn't include anything from this new feature branch that's ongoing, and you want to just create it, edit what was going on in master, and then pull those back in. And as you can see, each one of these commits has a unique ID, so they'll more or less be changed. And of course, after you merge hotfix into master, you can still merge this hotfixed code or update is53 from the master branch, or just apply these. And each commit has a unique ID. It'll mostly solve itself, except in some special cases, which are called merge conflicts. Once again, talking about later. And the other thing that we need to talk about is this fast forward. So under the hood, Git knows that, well, let's replicate what they have going on here. I want to list all the branches, and here's the ones we have locally. Let's say that, well, I mean, let's replicate it. And I'll git checkout -b a new branch that we'll call hotfix and I'll clone from wherever the master branch currently is. And what this does is this new branch is tracking the remote branch master from upstream SAM. So I can, do a git fetch to update everything. And then if there's something that changes inside of this remote branch, I can git pull. And where am I again? I'm on hotfix. What this is doing is it's more or less just set hotfix to actually keep track of what's going on in master. This isn't necessary, but it's useful. Of course, if you use the syntax here, let's blow this branch away. We'll switch back over to big main, which of course is inside of the main mixtures repository and is the stable production branch over there. Right, git branch dash d hotfix. And let's find out where we are. So this is where everything kind of is. It's the same as big main that we have locally, the main mixtures repository, new branch merge example, and so on and so forth. Let's just create a hotfix branch based at this point in time, without we'll create a new branch, we'll name it hotfix at this commit. Now, of course, if I get status, it says here, if I try to git pull, it's saying, oh, hey, by the way, we're not actually tracking anything, which is the opposite of what we did earlier. Depends on what you want to do. If you check out from a commit specifically, you're guaranteed more specificity about where exactly you are, because you can, of course, use the unique ID for any commit in any branch that your local repository is at least your local repository actually knows about, which you update with git fetch. Here you don't track what's going on inside of any other branch, and you're kind of over off by yourself. And you can end up in attached head states that way. But merging anything that you do inside of this branch is going to be pretty easy, depending on what branch you're merging it into. So to replicate this, let's go back to new branching example. And let's make a directory, changes, and we'll echo some output into the changes directory, which we'll have it at file 1. Which will be useful for another example, because I think that might introduce a merge conflict. We'll go ahead and git add. Now we have that commit, right? Technically, this is forward in time. from what's going on in either hotfix or the master branch or the big main branch that's tracking the main branch over in the main mixers repository. And now let's go over to our hotfix, where we're doing some other work for something new inside of that new branching example, but now I need to do something quickly to go fix what's going on in master. And maybe maybe I want to edit the README here. Blah, blah, blah. This is new information which needs to be incorporated into the documentation immediately, or something to that effect, right? And we'll git add everything in that directory. We'll git commit all of it with added docs which need to be added now. If we go ahead and git log, we'll notice that the hotfix branch doesn't really know about any of the other stuff that's going on. Bear in mind that commit that we did over a new branching example would normally be here, right? What we're going to do now is we're going to git check out our big main branch that we have locally, and we'll go ahead and merge the hotfix. Now, bear in mind, right? Now our main branch, or big main branch, doesn't know about any of the other changes we've done until we actually merged in. And because the internal Git repository that's actually keeping track of all of these branches knows that there's actually multiple commits that have been made in multiple branches, they're all checked out from the same core branch, it will do something called a fast forward. And we'll see that with git merge hotfix, which is where it skips past some of the other commits that have actually been made in the interim, because it knows that the hotfix branch isn't tracking them. Typically, this will never present an issue for you, but there are times where that can become important. And now, of course, we can see that our local branch that's tracking the main mixers repository main branch named master is now on the same point in the ledger as hotfix that we just created. And at this point, we might want to try to merge in. Oh goodness, what did I name that branch? So we're on big main, we just merged in hotfix. It's not in git toot. Was it in branching example? No? Okay. We'll git merge. It must have been new branching example. And we have to attach an actual commit message here because under the covers, Git knows that a fast forward occurred inside of our big main branch. And it's like, there might be something funky that actually happened in the interim. and maybe you want to revert that at some point in time, or you need a way to resolve it. Typically, at this point, if there is a merge conflict, it would tell you and ask you to actually fix that, and that's something done with git merge tool. Let's make sure. Yeah, we'll talk about merging issues soon. And we'll add in details about what we changed down here. Multi-line, list 1, list 2, etc., etc. Okay, and the merge was made by the recursive strategy. And you'll notice no fast forward was done. We took changes that happened in the interim, and we needed to make sure that everything lined up right. Because now, our big main branch is keeping track of what happened where. And in particular, it's going to, use our timestamp to actually kind of put these in sort of the right place to make sure that the version control history stays consistent. So now inside of my big main branch, I could roll back to where the hotfix was, change something in the hotfix, and then still hold on to everything that was going on in my new feature development, or vice versa. And that becomes a very useful tool when you have more than 3 people, let's say, that are all working on one file, because that needs to happen sometimes, or they could all be making edits to various aspects, and that needs to occur. So, one of the other key things is sometimes we need to actually prune all of these different branches, because like you can see here, when we list all of these branches, some of these have been merged in for ages, and it gets replicated across all of the different forks and different copies that people have. It's not necessary to keep those around, although an argument can be made for holding on to every single fix. This is a tool that accommodates that if you need to. So, we can get rid of that local branch. We've added it to our big main branch, and we can get rid of it if, like we've talked about in previous videos, if you're actually adding new code to send up to somewhere, you might want to hold on to that one branch, because it forms a nice time capsule. Branching can be used to form a little time capsule that's separate from everything else in case you have backups of files that you need to go back to at some point. Specifically if they weren't being tracked by Git before, and now you want to bring them into somewhere else. But we've done that in a previous video. So we can get rid of that, and we can, of course, where am I? Now, we did create this branch off of the main mixers repository, and we don't want to push directly to that. I want to push to my fork specifically. So let's go back and check the help. We can unset the upstream, and we can also set the upstream. So let's will it autocomplete for me? Let's get branch -- unset upstream main mixtures. And what we want to do is we want to set this to my copy of the master branch inside of my fork that I'm tracking. Set upstream 2. Let's use the shorthand here. It's a little bit more verbose. Set upstream. And now we're tracking specifically that. And I want to git push. And of course, we have different names. Remember, you probably want a -u here. But what we're going to do is we're going to start using some of the symbolic references. And this is wherever the head is located, which commit for master. And now, of course, if we actually go back over here, we can see that we've tracked those main changes that we needed to make into the same master branch. And you might be able to make a pull request out of that if a hotfix needed to be made.